talk about standard position in angles section 1. And standard position is having your x and y axis of just a normal coordinate plane, and putting the initial side of your angle on the positive x-axis, with your vertex being at the origin 0, 0, and then opening your terminal side either counterclockwise, that means going up, or counterclockwise going down. Now if you open it counterclockwise, that means you have a positive angle wherever it lands. And then if you open it down, which is clockwise, it will be a negative angle. And then wherever you land, that ray of your angle is called the terminal side. And then on a coordinate plane, you have 4 quadrants. You have the first quadrant, second quadrant, third and fourth. And the first quadrant is between 0 and 90 degrees if your terminal side lands in that. If it goes to the second quadrant, that's between 90 and 180. Third quadrant, 180 and 270. And fourth quadrant is 270 to 360. And then if you keep on spinning it, it can land back in the first quadrant again. It would just be more than 360, right? Because you can keep on rotating this angle as many times as possible. So it can keep on rotating around and around and around and around. And that's where we get in this idea of a coterminal. And so a coterminal is having 2 separate angles. Having 2 separate angles with the same initial side, which they all start at the x-axis, and then the terminal side where they end are exactly the same as well, but they're different measures. So for instance, this measure 420, so it starts at the initial side right here and it goes around and it ends right here in the first quadrant. So that measure is 420 degrees. Well, it looks the same as a 60 degree angle, so those are called coterminals. So 420 and 60 are coterminals because they start in the same spot and they land in the same spot, even though they have different measures. Now how I find that out is by taking my angle 420. If it's bigger than 360, I take 420 and I subtract 360, and that gets me 60 degrees. So that's how I can find coterminals. I also can continually add 360s. So if I take 360 and I add it to 420, that'd be 780. So 780 degrees would also be coterminals with those two, and you keep on just adding 360. Now on your homework and the problems that you were practicing on, what you're trying to do is trying to find the smallest possible positive coterminal, right? So if I'm given 420, I could get 780, but I want the smallest possible, so that's why I subtracted 360. But if you're given a negative, so like negative 75 here, to find its smallest possible, the smallest possible positive would be this one that starts from the initial side all the way and ends here. So on that, since it's negative, I'm going to add 360. Okay, so you're looking for the smallest possible. And if it's a really big number, say like 1375, okay, and I want to know the coterminal of the least positive. That's what they usually say, but it's the least positive. Well, I would continue to subtract 360 from this repeatedly until I got to the smallest positive number. Okay, and that's how you can do that. So say if you didn't want to continue to repeat multiplying by 360s, you can find multiples of 360, right? So if I take 375 and see how many 360s are in there, or in 1375, because I just divide that by 360. So that gets you about 3.8. So what that means is 1375 rotates 3 times around. So let me draw my initial side. Here's my initial side then. It goes 1, 2, 3, and then 0.8. Here would be a quarter. Here would be a half. Here would be 3/4, so 0.75. So a little bit more than this. So this is where our angle ends, right here. Okay, so that is 1375 degrees. Now, what I want to know is, okay, what's the least smallest positive, right? So the least smallest, I could have this negative angle from 0 down, right? That would be a coterminal, but I want the smallest positive, so that means I need to find this one, right? So that means I need to find this one, okay? So what we can do here is we can take this 3.8, and since the 1375 is positive, I can take 360. So I'm going to go, basically what I'm going to do is I'm going to go that 3.8 rotations, but I'm going to take away, I'm going to erase this as 0.8, right? And figure out, okay, what is that 0.8? So one thing you could do is probably just take that 0.8, that decimal that's left, and take that 0.8 and probably multiply it by 360, and that should get you this distance here. But a safer way, try to find this distance right here, okay, is take 360 and multiply it by 3. So that's 1080, right? So it goes 3 times around, right? It lands right here. And then that 0.8 goes from all the way to here. So that's what we want to figure out. So 1080 is back here at 0, right? So how much do I have to add to get to 1375? Or I could just subtract these, right? 1375 minus 1080, right? So that's 295. So that 0.8 distance right about here is 295, and that's the smallest positive, right? So 295 would be the coterminal, the least positive, or the least positive measure is 295. Okay, here, what about if it was negative? Now, if it was negative, it'd be a little bit different. So here, if we look at, say, negative 800, we want to find the least positive measure. Now, negative opens this way, right? So one would be 360, another one would be 720, and then a little bit more, right? 80. So it's not quite to 90, so somewhere right here. Okay, so there's our angle right there. And so the least positive, again, would be not the not just this distance right here, but all the way back from the beginning. So all the way from our x-axis here to our angle. So here's a little bit kind of trickier, right? So you could continue add 360 until you get a positive, or you can take this 800 and divide it by 360. So that's 2.2-ish, right? I'm rounding it there. So then I can take, instead of doing, because this is negative, right? I'm going to take that 2.2, and I'm actually, what I'm going to do with that 2.2 is times 2 by 360 is 720. Oops, 720 is 720. So that's 720. Right, so 720, even though it's going this way, that's okay. So let me erase all this. Alright, so we know our angle looks like this. It ends here, right? And we just want the least positive, so we want here to here. Right, because we want the positive one. Well, 2 rotations lands back at the x-axis, so we want to find out from here to here. Now 720 is 2 full rotations, okay? Now what would I have to get in order to come back around here? And because this one's negative, like the previous one was positive, so we actually rounded down, right? And then figured out how much do I have to add to get to 1375. Well, here, instead of actually going down, let's actually raise this 2.2, let's actually raise it up to 3. Okay, so if we raise it up to 3, then we would complete at 1080, right? Kind of like the last one here. So what that means is, instead of rotating 1, 2, and then 80, we're going to go ahead and finish this third rotation. And then we'll go ahead and subtract from our 720. We'll take this 1080 and subtract it, and we'll get that distance that we need. So whenever it's negative, you could round up. Whenever it's positive, you round down and times that by 360 and then subtract it from the angle that you have. So I'm going to take 1080. Right, that'd be ending right here. And then I'm going to take, or actually that would be ending all the way back at our x-axis here. But then I'm going to subtract the 800, the distance of finishing right here. And this is going to get me my, this 280 is going to be my coterminal. It's going to be the distance from here around to where my angle stopped. So that might sound a little confusing. So if you want to, you can just continue add 360, add 360, add 360 until you get a positive number. So this way, to begin with, might not seem like a shortcut. But maybe eventually with really, really big numbers, if you get like 5,760 and you're trying to find the coterminal, the least positive, then this multiplying thing would work. So the key here is if it's a positive measurement and you're trying to find the least coterminal, go ahead and take that degree divided by 360. Okay, and whatever number you get, so you get 5.7. Okay, what you're going to do is, if it's positive, you're going to round down to 5. Okay, you're going to round down to 5 and multiply that by 360. Okay, and then take that amount, take whatever that is, and subtract what your angle is. Okay, if it is a negative degree, you're going to divide that by 360. Whatever you get, say it's 4.3, you're going to round down, multiply that by 360. Okay, and then take that number and subtract your angle, but subtract the absolute value of that number. Don't worry about that negative. Okay, so that's kind of how you do that. Okay, so here's a word problem kind of dealing with the same thing. You have this disc that's being revolved around a record or CD player that's going around revolutions, right? Each revolution is 360 degrees. So you got some CD player. There's a point on the edge, and it's being rotated around 480 revolutions per minute. So every minute it's going 480 revolutions, right? Which every single revolution is 360 degrees. And what we want to do is find out how many degrees it goes in 2 seconds. So first what we want to do is figure out, we're going from minutes to seconds. So how many seconds are in 1 minute? That's 60, right? So we want to calculate how many revolutions per second does it go, right? So that means we're not going to multiply 480 by 60, but we're going to take 480 and divide by 60, right? Because we're figuring out how many per second, right? How many revolutions per second. So that number needs to be smaller than 48, because if it's bigger than 48, that means every second would be bigger than 480. That means after a minute you would have more than 480. So that's why we divide by 60. So we're going to take 48 and divide it by 60. So we get 8. Right? So we get 8 revolutions per second, and then we're going for 2 seconds. So if we times that by 2, we get 16. We get 16 revolutions, right? So we're making 16 revolutions, and then if we have 16 revolutions, that's how many times around? 16. And how many degrees is one time around? Well, that's 360. So if we take 16 and we times that by 360, then we get how many revolutions we make, or how many degrees we travel, which is 5,760 degrees. Another way to do it is to set up kind of like you do in science, like this, right? I have 480 revolutions per minute. I times that by, so then I can cancel these because there's 1 minute in every second. So I'm trying to figure out how many seconds. And so we set up that proportion, and then we go ahead and cross multiply, which means we're taking 48 divided by 60, and then 360 degrees in every revolution, right? So then the revolutions cancel out, and so all we get left is with seconds. Then we can times that by how many seconds we're traveling, which is 2, and then we get our degrees, right? So then the seconds are going to cancel out, and then we get left with this degree, right? So 5,760. So let's go ahead and do some homework problems. Okay, so here are the ones. We've already done those other ones before. Let's go ahead and look at 77, 87, 91, and 131. Okay, so here we're finding the coterminal of least positive measure of negative 40 degrees. So if you want to, you can draw it. It's negative, right? So that means it's going to go up and down 40. This right here is 90, right? So it's going to be less than that. So it's probably somewhere right there, right? So there's negative 40 degrees. So we want the least positive. That means we want this distance right here. Okay, so one full rotation would be 360, right? Negative 360 degrees. So what we want is we just want this distance, right? This distance in blue, we want that distance. So if we just take 360 and we subtract 40, then we can go ahead and get 320. So 320 degrees. That's would be the coterminal of least positive. Or you could add you could just add 360, right? Repeatedly until you get a positive. You get your first positive. Okay, let's look at number 87. Okay, 850. So this one's a little bigger. The bigger ones are tougher, right? So what you can do is you're going, right? So you're going positive. So 1 full rotation. 2 rotations is 720. So 720. So 720. So if I take 850 minus 720, okay, then I get 130. 130 degrees. So actually I don't go this far, I actually come back and I end somewhere about right here. So this is actually my angle. Starts initial side and it does end about in the second quadrant at 130. So really I just want this distance from here to here, right, which is 130. So see how I kind of figure this out? Maybe not, but I just count. Basically what I did was subtracted because this is positive, I just subtracted 360 from it until I got a positive number. Okay, again what you could do is you could divide that by 360, and what you would get would be 2 point something, well that'd be 2 point probably 3, somewhere around there. So if I round down, because that's positive, I want to round down. So I get 2, I times that by 360, that's 720. And then I take my angle minus 720, that's how I got the 130. Okay. So now we can go at 91. So number 91. Okay, so let's take a look at 91. This is kind of a hard one. Negative 5,280. So because this is negative, if you do the dividing by 360 thing, then whatever you get, you're actually going to round up. And whatever that number is, it's going to be, if you round up, it's going to be bigger than 5280, right? So then you just take that number and subtract 5280. It doesn't really matter that it's negative. Okay, so if I divide that by 360, I think I get, let's see, so it's approximately, 14.6. So if I round up this time and get 15, that means I'm going to have a bigger number than this, right? Which would get me a positive number. So I want to take 15 times that by 360. So that equals 540, or 5,400. So I'm going to take 5,400 and I'm going to subtract 280. So that's 120. So 120 degrees would be the correct answer to number 91. So that's the coterminal of least positive. Okay, let's go ahead and do number 131. So 131, you have a turntable. Okay, so you have some kind of turntable here. And a shop that makes 45 revolutions per minute. So this is rotating around. If you have a dot somewhere here, it's rotating around 45 revolutions per minute. So that's 45 revolutions per 1 minute. And we want to figure out how many revolutions. So we want to find out revolutions per second. So how do I change minutes to seconds? Well, there's 60 in 1 minute. There's 60 seconds, right? So the minutes will cancel out here. I'll take 45 and divide that by 60 because the number should be smaller, right? It can't be bigger because then I would have more revolutions in 1 minute, right? So that's why I'm going to divide by 60, not multiply by 60. So that's 3/4, right? Which is 0.75. So 0.75 revolutions per second. Okay. And this makes sense, right? For every second that goes by, we make a quarter of a revolution, right? So that means, or 3/4. So that means if we start here, in 1 second we're right here. Okay, and in another second we're right here. And if we do that, 60 times, because there's 60 seconds in 1 minute, that would equal 45, right? I could take 0.75 multiplied by 60 and we get 45. So there's our answer.